Welcome to my channel Ganit Matrix. If you are preparing for engineering mathematics courses for universities like JNTU H, JNTU K, JNTU A, you are in the right place. Now I specialize in breaking down difficult exam problems into clear step-by-step solutions, so you can walk into your exams with total confidence. And this is double integral over general region problem series, problem number 4. Evaluate double integral xy dx dy over the positive quadrant of the circle. Circle x square plus y square equal to a square. So this is a circle with center 0, 0 and radius a. So first we identify the region. Since this the region is in the first quadrant of the circle x square plus y square equal to a square, circle centered at origin with radius a. Since in first quadrant our x is positive and y is positive, boundary x square plus y square equal to a square. So x equal to 0 here and y equal to 0 here, and x square plus y square equal to a square. So x square plus y square equal to a square, that means y square equal to a square minus x square. So y equal to root of a square minus x square. So we will take positive root of a square minus plus root of a square minus x square, because this is in the first quadrant. Y equal to root of a square minus x square. Now I am taking the order of integration dy dx. That means first we integrate with respect to y, next with respect to x. Since first we are integrating with respect to x, so we will take vertical strip. Now how to find the limits? Draw the vertical strip through the region and identify where the strip enters the region and where the strip leaves the region. Since the strip enters at y equal to 0 and leaves at y equal to square root of a square minus x square, because y limits must be functions of x, and like x limits are constants if we take the order of integration dy dx. So through the vertical strip, so we are getting y limits must be functions of x, and x limits are must be, so if you see the region, the leftmost point is origin, so this is 0, x0. The rightmost point for this region is a. So x varies from 0 to a, y varies from 0 to root of a square minus x square, and our integrand is xy dy dx. So plug in these limits, integral 0 to a, integral 0 to root of a square minus x square, xy dy dx, and remember that these are the y limits, right? The inner integral corresponding to y and the outer integral corresponding to x, right? So how to evaluate this? First we integrate this with respect to y, treating x as a constant. So we will write x as it is, integration of y is y square by 2. Plug in the y limits, y varies from 0 to root of a square minus x square dx. So plug in the upper limit, so this is a square minus x square by 2 dx. So 1 by 2 constant, take out of the integration, so this is a square, multiply x with this numerator a square minus x square, this is a square minus x cube dx, which will be integrated with respect to x between the limits 0 to a. So 1 by 2 a square constant, integration of x square by 2 minus integration of x cube x power 4 by 4. Same thing here, we are using that formula, integration of x power n dx equal to x power n plus 1 by n plus 1. So this is 1 by 2 into, now substitute the upper limit, a square x equal to a, so a square into x square a power 4 by 2 minus x power 4 a power 4 by 4. So taking the LCM with 4, so this is 2a power 4 minus a power 4 by 4, which is a power 4 by 4. So finally this is a power 4 by 8. Thank you.